Alright, in this video I'll be doing those three problems you asked about. For number 17, I'm going to use 330. I think the one that I saw was 420 degrees, which is coterminal. If you subtract 360, you end up at 60 degrees. And 60 degrees is in the first quadrant, where all the trig ratios are positive. So that's not all that interesting. Let's go ahead and do 330. Remember, 360 is what it is all the way around, so it's 30 degrees shy when you have an angle starting at the initial side. We go all the way around to here. That's 330 degrees. Subtract that from 360, that makes this 30 degrees. Actually, I'm going to make this a little bit longer. So this is what we call a reference angle, and we're going to be using one of our special triangles. I want to remind you there's two special triangles that you ought to know, the 45, 45, 90, where we make each leg 1, and if you use the Pythagorean Theorem, you would find that the hypotenuse is the square root of 2, if you start with these two legs being 1. Whatever your leg is, if you multiply that by the square root of 2, that will always be your hypotenuse. So if we make it 1, it makes it nice and easy. Similarly, you can work with a equilateral triangle and get the 30, 60, 90 degree triangle. And if you make the shortest leg 1, notice it's opposite the shorter angle, the hypotenuse is double the shorter leg, and the longer leg is a square root of 3 times whatever the shorter leg is. Well, since it's 1 here, square root of 3 times 1 is the square root of 3. By the way, the birds are really loud outside. I hope you're not hearing all that. Hopefully you can hear me better. Okay, so in this case, if we want to find, well, let's see, before we get into that, just real quick, I'll show you how I like to remember these trig ratios. Sine is opposite over hypotenuse, or y over r, and cosine is adjacent over hypotenuse, or x over r. And it turns out that tangent is sine over cosine, and if you put these fractions one over the other, you end up with opposite over adjacent. It's just the numerators here. Opposite over adjacent, that's tangent. Now the reciprocal of sine is cosecant, so we just flip what we had here. Same thing with cosine and secant, and tangent and cotangent. And so that's how I remember those. The other thing I would say is sometimes students will memorize these different ratios for 30 degrees, 45, and 60, and so that certainly makes the process a little quicker, but I think for most people it helps to just draw a picture like what we're doing here. So I'm going to make my 30, 60, 90 degree triangle right here. Again, this is my reference angle in here, the 30 degrees, and we know the shorter leg is 1, the hypotenuse is 2, and this leg is the square root of 3. And so let's see, we're going to do sine of 330 first. There's really a couple of ways you can do this. I'm going to go ahead and, looking at this picture, you can see that if you actually put a point here, remember we know that we can use x and y in our ratios. This would have to be a negative 1. So the distance from here to here is the square root of 3, and the distance here is negative 1. And so it's going to be y over r, or opposite over hypotenuse, so that's going to be negative 1 over r, which is 2. And so we get negative a half. For cosine of 330, it's going to be x over r, which is the square root of 3 over the square root of 2. For tangent of 330, it's going to be y over x. In this case, y is negative 1, and x is the square root of 3. Now, we don't normally write it that way. We need to do what's called rationalizing the denominator. If you multiply the square root of 3 times square root of 3, you would get 3, and you get rid of the radical in the denominator, which is what we want. In order to make it legal, you got to multiply the numerator by square root of 3. So we're really multiplying by something that's equal to 1, and that's why the value doesn't change. Negative 1 times square root of 3, this will be negative square root of 3. Now, I kind of ran out of room here, but I would want to do my reciprocals over here. So for sine, the reciprocal is cosecant. So cosecant of 330. It's just going to be this flipped, so 2 over negative 1 or negative 2. And secant of 330 will be 2 over the square root of 3, but we got to again rationalize that denominator. So we get 2 square roots of 3 over 3. And then finally, for tangent, for cotangent of 330, it's going to be, see, instead of using this here, I would use what's here. It's going to be square root of 3 over negative 1, or that's just negative the square root of 3. All right, and so that's number 17. Let's move on to 23. So you have a building that's 80.46 feet tall, and you have a shadow for that building that's 84.51 feet, and we're supposed to find the angle of elevation. So first of all, I'm going to draw my building, or something to represent my building. And we'll put the shadow off to this side, so this is the shadow of the building. Now it's a little longer than the height, so I'll make it longer than this side. And then this goes here. And basically the sun would be over here. And this is what we call the angle of elevation. This is the horizontal, or basically the ground. And from the end of the shadow, the angle of elevation to the sun is what we need to find. So let's call that theta. And then we said this was 80.46 feet. This is a right triangle. And this length here would be 84.51 feet. All right, so we were asked to find this angle. So this is a right triangle. Let me pull this. Let's see, we'll do this. So we need to find this angle, and we know two of the sides of the triangle. We know the opposite side, and we also know the adjacent side. We don't know the hypotenuse. So think about which of your trig ratios deals with the opposite and the adjacent. That would be tangent. The tangent of theta is opposite over adjacent. So that's going to be 80.46 over 84.51. The adjacent angle or side is always one of the sides that makes up the angle. The hypotenuse is the other one. All right, so to find theta, we have to use the inverse function. It will be tan inverse of 80.46 over 84.51. So if tangent of theta is equal to this, then theta is going to be the tangent inverse of this. So basically, theta is the angle whose tangent is this value. And so let's put that into our calculator. So we're going to hit second and then tan 80.46 divide 84.51. Notice I'm in degree mode. You can always click on mode and make sure you're in degree mode. And when you hit enter, we get theta is 43.6. And I believe you had to round to the nearest tenth. And so that's degrees. All right, that's number 23. Let's move on to number 24. All right, in this one we have two ships that leave a port. One leaves at 42 degrees. That's the bearing. At 26 knots per hour. The other one is 132 degrees at 18 knots per hour. So we're supposed to find out how far apart are after 1.5 hours. And I'm kind of running out of room. I think I'm going to do my picture on a separate page. Okay. So they're starting out at the same port. The first one leaves at a bearing of 42 degrees. Now that's measured from due north. And so we're going to go 42 degrees clockwise. And so 45 would be about halfway, well, half of this 90-degree angle here. So it'd be maybe around here. Actually, I'll make this a little longer because this is the one where we're going at 26 knots per hour. So 26, and we'll just put K in per hour. And this angle here is 42 degrees. Now this other ship goes at a bearing of 132 degrees. Well, 130 degrees, well, we know this is about 90 from here to here. And another 30 would be about 120, so I don't know, we'll say it's somewhere around here. We're just estimating, and actually this should be a little bit shorter because the distance we're going to travel is going to be a little it's going to be less because we're only going 18 knots per hour. Now it says, how far are they apart after 1.5 hours? Well, that's going to be this distance here. So this is what we're looking for. We're hoping this is a right triangle because that's all we know how to work with so far. And so, let's see, we said that this angle here was 132 degrees. So we should be able to subtract this minus this, and that'll give us this other angle. And if you do 132 minus 42, you're going to find that's 90 degrees. And so that does make this a right triangle. And so that's going to help us a lot. Now, there's something else we need to do here. We only have the speeds on here right now. I actually need to know these distances. Well, you have a formula. It's d equals rt, or distance equals rate times time. So, for example, if you were going 80 miles per hour for 2 hours, then you would go 160 miles. So that's just an example of driving in a car. In this case, for the first case, we're going 26 kilometers an hour, and we're doing that for 1.5 hours, so that's going to tell us the distance that we travel. And in the second case, we're going 18 miles or kilometers per hour, not kilometers, knots. And so let me go ahead and multiply those out. So that's 39 and 27. So this is 27 knots, and this is 39 knots. Now, in this problem, we don't know either of these angles. So we could certainly, if we had one of them, we could find this length. But in this case, if I have two legs of the right triangle, I can find the hypotenuse. In fact, if I have any two sides, I can find the third side. We're going to want to use the Pythagorean Theorem. So we've got 39 squared plus 27 squared equals c squared. We're going to end up with c equals the square root of 39 squared plus 27 squared. So let me go ahead and plug that in to my calculator. And I'm getting 47.4, rounding to the nearest tenth, which is, I think, what they want. So if this was 27 and this is 39, it makes sense the hypotenuse should be longer. And sure enough, we're getting 47.4. All right, so that's it for those problems. If you have any questions, let me know.